Okay, so this next unit is all about rational expressions. Rational are numbers that can be written as fractions. Expressions means that it has to contain, an x or some sort of mathematical. So these are not just fractions, but they're going to be fractions involving various algebraic expressions. It's going to consist of being able to factor and being able to then cancel out like terms. Okay? So those are the two things you need to know how to do. You need to know how to factor, and then you need to be able to recognize when you have like terms. When you have like terms, you can then cancel them. Okay? So the first example we have up here is just actually a review of problems that we've done since, I think, the first week of school, just making sure that we're on board with canceling like terms. So it's 4x squared y over 2xy cubed. How do we know what we can cancel here? Or what can we simplify here? Okay, so the 4 and the 2. So 4 over 2 would simplify down to what? To 2, okay? We have x squared over x. What would that simplify down to? X. And then we have a y over y cubed. A y squared, and a y squared would end up being in the denominator. Okay? So that's just a review of what we've done. So now, when we have problems like this, we can just look at it and cancel because everything here is attached with multiplication. That's the key. In order to cancel things in fractions, it needs to be attached with multiplication. Okay? If it's not, we can't cancel it. So 2, we have 6x to the 5th minus x to the 4th all over x squared minus x. So when you're looking at this problem, we see that there's subtraction signs on both the numerator and the denominator. That tells us that we can't cancel anything yet until we get some multiplication in there. Well, how do we get multiplication in a problem that has subtraction? What type of factoring could we do to both the numerator and the denominator?
Multiply it by.
Not multiply it, no. What type of factoring? What's the first type of factoring that you were always supposed to look for? Greatest common factor. That's still the same case. Always look for a greatest common factor. So is there a greatest common factor in the numerator? What is it? X to the 4th. So in the numerator, we're going to take out an x to the 4th. If we take out an x to the 4th, what are we left with? 6x minus 1. When we take an x to the 4th out of x to the 4th, we still have 1 left over. Okay? Over. What's the greatest common factor in the denominator? X. When we take the x out, what do we have left with? X minus 1. Yep, x squared minus x. So now we want to take a look and we want to go, okay, is there anything now that matches exactly? So if these parentheses were to match exactly, we could cancel them. Do they? No, they're not quite exact. So then let's look at the values that are being multiplied out in front. X to the 4th over x. Could we simplify that down at all? How would that part simplify down to?
X to the 3rd.
Yeah, we would just have an x to the 3rd in the numerator. So now that would be as much as we can cancel, as much as we can simplify. So to write this out in simplest form, we don't want any parentheses. So we'll distribute the x cubed back through, and we'll leave the x minus 1 alone. So if we distribute the x cubed back through, we would have 6x to the 4th power minus 1x to the 3rd, or just x to the 3rd, all over x minus 1. And now that would be simplified. Okay, so we can only simplify when we're attached with multiplication. So when we took that greatest common factor out, we were then attached with multiplication, so we could then simplify those terms. All right, so let's do a few more here. Number 3, t squared minus 25 all over 8t squared plus t minus 20. So we still always want to look for a greatest common factor. Is there a greatest common factor here? No. Not in the numerator, not in the denominator. So we want to see how can we factor this.
Isn't that like a square up there?
Yeah, those are both perfect squares. So how can we factor t squared minus 25?
T, like square root.
We can't square root it, no.
You can square two parentheses.
So t and t would be our first terms. What would be our last terms to make our outside and inside 0? Yeah, plus 5 and minus 5. Remember, this is called a difference of squares. It's going to always factor to a plus and a minus. And then t squared plus t minus 20. It's got to be t and t again. We want our outside and our inside to give us a plus t. We want our last terms to multiply to give us a minus 20. What are the factors of 20 that would do that? 4 and 5, good. Should I have plus 4 minus 5 or plus 5 minus 4? Good, plus 5 minus 4. Okay, so that's our first step we factored. Now we're attached with multiplication, right? We have the parentheses next to each other, so we're attached with multiplication so we can see if we have anything that's alike that can cancel. So, yeah, the t plus 5s are absolutely alike in the parentheses. So we can cancel the t plus 5s, and we are left with t minus 5 over t minus 4. And that would be our simplified answer. Is that okay? All right, let's look at 4. 8y squared minus 32 all over 4y squared minus 16. So first off, is there a greatest common factor in the numerator?
No.
There's 8. So let's take the 8 out. Okay, so in the numerator we have 8. It would be 8 times what? Not just 4, y squared minus 4, all over. Okay, is there a greatest common factor in our denominator? 4 times, good, y squared minus 4. Yeah, now I know we can factor y squared minus 4 further, but right here, are these parentheses identical? Yeah, so we can cancel them right at this step. Okay, then we have 8 over 4, which is just 2. Yep, it's just 2 because 8 divided by 4 is 2. Is that one okay? All right. Number 5, b squared minus 10b plus 21 all over b squared minus 11b plus 28. So first off, are there greatest common factors in either the numerator or the denominator? No greatest common factor, okay. So then we're going to try to factor these trinomials. So in the numerator, what do my two first terms have to be? Yeah, b and b. Okay, I'm looking for factors of 21, and I want my outside and inside to give me a negative 10b. 7 and 3, and should they both be minus or both be positive here? Both be negative because we want a negative 10b. Okay, now the denominator, we're going to try to factor it. We know the first terms have to be b and b. Now we want factors of our last term of our 28. That'll give us an outside and an inside of minus 11b. 7 and 4 are both negative. Good. Okay, so which one will cancel here? Good. The b minus 7s will cancel. They're exactly the same. So we are left with b minus 3 over b minus 4. Is that one okay? Now what do you think happens if you factor this and you see that nothing cancels? What do you think that tells you? You made a mistake someplace. I'm going to give you problems that will have something cancel. Okay, so if you go through and factor and you're seeing that nothing is canceling, go back and double check that you factored it correctly. Okay. Number 6. 6 minus y over y squared minus 2y minus 24. GCF anywhere? Nope. Okay. Does our numerator look like it's pretty much as simplified as we can get? Okay, so let's try to factor the denominator first then. So what are the first terms? Y and y. Okay. Now we want factors of 24, and our outside and inside should give us a negative 2y. 4 and 6. Good. Which one should be the negative one? 6. We'll say negative 6 plus 4. Now I want us to have some foresight. What's the numerator right now? 6 minus y. Does that look kind of close to this? How can I make it look exactly like this? What do I have to take out of 6 minus y to make it y minus 6? I have to take out a negative 1, yeah. If I take a negative 1 out of this, that makes my 6 negative, and that makes my minus y positive. So 6 minus y is the same thing as negative 1 times y minus 6. Okay, now do I have anything that will cancel? The y minus 6 as well, and I'll be left with a negative 1 over the y plus 4. Okay, so that's something to look for. When your factors are subtracted and they're just in the flip-flopped position, you always just have to take a negative 1 out of one of them, and then you will be able to get them to cancel. Okay, we got 2 more examples. Number 7, x to the 4th minus 16y to the 4th all over x squared plus 4y squared times x minus 2y.